Hello everyone, welcome to today's Labs Learn Know session. I'm Ben, a senior data scientist at Relational Labs Singapore. I've worked in the areas of language processing and knowledge graph for almost 10 years. Let me start today's session by introducing what knowledge graph is. A knowledge graph is a structure representing facts where facts can comprise of entities and relationships. But let's move away from this standard definition. I'll explain what knowledge graph is by using this hexagon model in this slide. The world in the diagram represents what we see and encounter, for example, entities and events. We often have mental model how we view or what kind of descriptions we could possibly have to describe or represent these entities. This will eventually lead to the symbolic model, where it will act like a catalog of words, and from here it can be further organized into a more formalized structure, where it is called as an ontology. This puts a structure to organize concepts in a hierarchy. Ontology will be a meaningful start to knowledge graph, and this hexagon model expresses the need of expressiveness for a representation model of frameworks to handle the complexity of natural language. Before I go a deeper dive into knowledge graph and the different representation frameworks, let me explain briefly on the main differences between graph and relational database. Most of us in the software development field would be familiar what relational database are, where the data is stored into a table, where it further comprises of columns and rows. This still decent to do some aggregation work for the data stored in multiple tables, but this has some limitation to the aggregation. Try to imagine we have to do massive amount of work of aggregating multiple columns across different tables iteratively. This can be an expensive task. This is where graph database comes into play, where it acts naturally to link data across with a flexible schema where relationships is already expressed at the fundamental level. Now let's take a look at the different representation frameworks on how we can store knowledge graphs. In a graph representation, we represent things or concepts as nodes. We use edges to represent linkages or relationships, and also the use of properties to store metadata as a key value pairs. Here we see there are two main frameworks. One is called Label Property Graph, and the other is RDF, which stands for Resource Description Framework. We can see major graph vendors organize themselves accordingly to this type of frameworks. I'll move on to the next slide to describe the differences between the LPG and RDF graph. In the label property graph representation, you are able to add identifiers and set of attributes to a node to describe what it is. Similarly as well, you can do this to represent relationships with identifiers and attributes. This is something that is lacking in the RDF model. For RDF, to represent the nodes, we can add identifiers, where we can use URI to assign a unique identity to a node. Or we can take another form as literals, where we can add attribute values as string, float, datetime, integer, and so forth. Relationships also take a form in URI, where I will elaborate further in the next slide. This allows the agility in the process of creating knowledge graph, where there are existing open standards to help in facilitating this. Let's take a further look into the differences between the LPG and RDF models. In this slide, RDF does not uniquely able to distinguish instances of relationships of the same type, and it does not have the additional attributes that can be added to support for this. In the diagram, we can see that we have like employee, company, and city nodes. In the LPG model, we can enrich or add semantic descriptions to the relationships to the both of nodes and relationships. For RDF, there's a workaround to do similar like to what LPG can do. This is to perform a process called verification by creating a metagraph. What is a metagraph? A metagraph is a blank node where this function is like a placeholder where additional relationships can be added to store these attributes. As for the next difference, RDF uses triples and quads as a form to store the graphs. A triple comprises of subject, predicate, object, where predicate is referring to the relationship, and we can think of a triple is representing a fact. In RDF, we can use quads as a placeholder to park all these triples under a context. There are many practical usage of quads, where quads help to partition the huge graph into a manageable subsets of graphs, and we can assign different contexts to these subsets. A context can refer to different data sources where the graph was created from. We can also use this additional URI for this context for data provenance to keep track of the source of data. Another usage of context is it also can be used as for versioning purpose to capture the creation and modification of these triples as well. In our project for infrastructure, we use quads as a way to assist to capture temporality for the stored graphs. To recap, why we use RDF compared to LPG is because there are existing open standards out there, for example, like time ontology and schema.org. How all these facilitate the ease of creating knowledge graph by reusing these schemas that can be imported easily. So next, I will come to the question of why are knowledge graphs underutilized. First of all, as what we've discussed, the representation framework like LPG and RDF requires a good depth of understanding what this framework can offer and how does it actually work best for the type of data. These will eventually lead to decide what is the right technology stack. For example, so to decide the choice of your graph database. And further complexity will just kick in terms of like how to set this database up, how to design, build some sort of a robust, scalable ingestion pipeline to convert this into graph, and also what kind of analytics once all this is already in a formal graph, how it can be actually be applied. Domain knowledge also plays an important part as well. For example, domain ontologies or schema that is open available out there, especially for other industry domains, actually are far more developed compared to the financial domain. So okay, come to the right now to the poll question. Where do you think knowledge graph will have the biggest impact in finance? Can it be used in database management to link siloed databases? Or can it be useful in compliance functions, for example, like fraud detection, KYC? Or can it be used as an enabler to build recommendation engine for risk assessment and monitoring? Or lastly, for time series analysis? Okay, that's interesting. It seems there's 34% from the poll that knowledge graph will be useful in compliance. Alright, now I think it's time for me to pass the session to my colleague Swanima to take us through of how we use knowledge graph in our infrastructure project. Thank you.